The goal for 7.1.4 is, again, just to continue to work on our two-column proofs. Ideally, you should be pausing the video and trying these problems in your notes first, and then coming back to the video to see kind of how you did, right? So looking at question number 46, right, what we want to do is we want to figure out a two-column proof to prove each question. All right, so looking at A, we want to prove that the diagonals of a rhombus bisect the angles. So again, what we're trying to prove is that ABD, right, so this little angled guy right here, is congruent to CBD. So we're trying to prove that these two are congruent to each other. Okay, so go ahead and pause the video now and try A on your own with a statement and a reason. So statement and reason. Okay, so if we're coming back from the paused video, we want to start off with what we know. We know that this is a rhombus, so I need to write that down. So I'm going to say ABCD is rhombus. Why? Because it was given to me. Okay? All right, so what do I know about a rhombus? Well, again, if I look at my definitions of a rhombus, it says it's quadrilateral with 4 congruent sides. So that is important to know. So I know that this side is congruent to that side, which is congruent to that side, which is congruent to that side. So I need to figure out kind of what I'm trying to figure out, okay, and how I want to use it. I'm going to use side, 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 because that seems pretty reasonable. So I'm going to say that AB is congruent to CB. Okay, so I'm saying that that side, and I'm going to put it in, I'm going to color coordinate it. So I'm going to say that that side is congruent to that side. And why? I get to say definition of a rhombus. So that's exciting. And then I'm going to say that this side is congruent to that side. So AD is congruent to CD. And again, definition of a rhombus. Okay. Next thing I want to put is I want to put this middle line right here. So I'm just going to say that BD is congruent to BD. And again, why do I get to say that? It's the reflexive property, right? Or congruent. It's congruent to self. So now that all of my sides are congruent to each other, these triangles are congruent. So I get to say triangle ABD is congruent to triangle CBD. And I get to say a side, side, side congruency. Therefore, angle ABD is congruent to angle CBD. Why? CPCTC. Or again, congruent triangles have congruent parts. Either one is perfectly fine with saying this. Okay, so again, hopefully your flowchart has something, your two-column proof has something like this. All right, let's look at number 2. So in chapter 2, we use congruent triangles to prove that if a triangle is an isosceles, then the base of the angles must be congruent. We want to write the converse of this statement. So it says, how can you prove this? So the first thing we want to do is we want to write a converse. So our converse for part B will be this, right? If two base angles of a triangle are congruent, then the triangle is isosceles. So again, converse just means can we make it backwards? So again, we're going to assume that E and G are our angles. We want to draw our line. So go ahead, pause the video now, and try making up a two-column proof for this one. All right, so B is going to be a little bit more challenging because it is asking us to draw this auxiliary line. The first thing we're going to do is draw that line that we're talking about. So here is an auxiliary line. And why are we doing this? We're doing this so a way it cuts into two equal triangles. Basically, we want to bisect letter F. So again, statements, reasons. One of the first things we're given, we are going to say that angle E is congruent to angle G. And again, that was given information. Okay. We drew an auxiliary line. Why do we do that? That way we could have, let's write this as another letter. Let's just, I don't know, M. Okay. So we did this so we can have a side. And so we have an angle and we have a side. So maybe we could do like angle, angle, side. So I'm going to say FM. So FM bisects the angle EFG. And I'll also say and point M, since I had to write that, lies on EG. And why was I able to write all of this down? I was able to draw an auxiliary line. So we're going to say an auxiliary line drawn to bisect angle F. That's why I was able to do it. Okay. So now that I get to say that this bisects it, now I get to write this. So I get to say that angle EFM is congruent to GFM. And I'm going to say a definition of an angle bisector. Oops, spelled bisector, right? Bisector. So that's great. So I got that guy and that guy are the same. And now because I drew FM, I also get to write this. I get to say that FM is congruent to FM. And we'll say reflexive property. Reflexive prop. So again, I have angle, angle, side. So last but not least, I'm going to say that triangle EFM is congruent to triangle GFM. And I'll say angle, angle, side. Again, what am I trying to prove? I'm trying to prove if two base angles are congruent, then the triangle is an isosceles. Well, in order for it to be isosceles, these two sides have to be the same. And it is. They are the same because these triangles are now the same. So I'm going to say that, what is the letters? EF. So EF is congruent to GF and Y, CPCTC. And based on this information, I now get to say that this giant triangle EFG is isosceles. And again, this is the definition of an isosceles triangle. So again, this one was a little bit more challenging than the first one. Okay. So let's try the last one. So again, what can congruent triangles tell you the fact of diagonals of the rectangle? So use the fact that from a previous chapter we said, or section, we said the opposite sides of a rectangle are parallel, because we've already proven that information. Okay, and we are basically saying this diagonal. So we're going to say what's going to happen with our diagonal. So again, we should probably, I'll help you out with this. Prove that angle HKJ is congruent to IJK. So we're going to kind of IJK. Okay. So my suggestion is kind of make it look like two different triangles. So kind of draw it out like this and like this. So we have HKJ, and then IKJ. Again, when you think you have some sort of flow chart or statement of reasoning to column proof, comment on pause it, and we'll see how you did. Okay, so if we're coming back, we are going to create a statement and reason. So statement and reason. So the first piece of information we should write down is that this is a rectangle. So we have H, I, J, K is a rectangle, and that was given information. What else do we know? We said use the fact that opposite sides are parallel, so we've already proven that fact. So I'm going to say HK is parallel to IJ, and also say that HI is parallel to KJ, and Y, we've already said opposite sides of rectangle are parallel. Okay. What else can we say about this is that if they are parallel, okay, that this is a parallelogram. So now I can actually say HIJK is a parallelogram. Ends definition of a parallelogram. Okay. What else do I know? Okay, I know that that HK and IJ are congruent to each other. So I'm going to say HK is congruent to IJ. Basically, this side is congruent to that side, and opposite sides of a parallelogram are congruent. So we have to say that. So now I got this. I know that this is a rectangle, so I know that this angle and this angle are both 90 degrees. So let's say that the measure of angle K, and I know which triangle, or since I don't really know which triangle I'm talking about, let's use 3 letters. So HKJ is the same thing as the measurement angle of IJK, which is 90 degrees. And again, this is a definition of a rectangle, because a rectangle has to have 90 degrees. If they are equal to each other, we know that they are congruent to each other, which is great. So if you wanted to, you could put that information. We could say that HKJ is congruent to IJK, and definition of congruency. So we could say that kind of brings us back to previous chapters. So now I have side, and I have a side, I have an angle, and I have an angle. So last one is going to be this guy right here. So this side is going to be congruent to that side because they're the same thing, right? That's the same. It's the same side in both of our triangles. So I'm going to say KJ is congruent to JK. And why do I get to say this? It's reflexive property. So that's exciting. So now I figured it out. I have side angle side. So I'm going to put down that triangle. HKJ is congruent to IJK. Why do I get to say this? Angle, side, angle. What do I now know about the diagonals? Is they now have to be congruent to each other. So now I get to say that HJ is congruent to IK, and again, CP, or I could have written this. Congruent triangles have congruent parts. So either one is perfectly fine. Again, hopefully you have something to this effect for these 3 practice problems.